I have to say it is a great honor to be here again. I was here for the very first JavaDay in Ukraine, and yes, there were a lot less people there for the first event, so it's great to see so many people. And I have to say that, you know, I've been talking about Java for a long time now. I've actually been talking about Java for over 20 years, which is kind of scary, because I was at a conference last year, and I was talking to somebody, and he said, oh, you've done a lot of things in Java, haven't you? And I said, yes, I started working for Sun back in 1996. And he said, I wasn't born then. So it was kind of interesting to think how long I've actually been doing this. And one of the great things is coming to an event like this, where it's a Saturday morning. You have given up your free time to come and listen to me. That's an incredible thing for me to actually see. Right. And let's get on with the presentation then. Now, originally I was going to just talk about JDK 9 for this presentation. And I thought, actually, I think it's going to be more interesting to talk about JDK 9 and what's happening next. Because there have been a number of announcements that were made just before Java 1, so this is about 6 weeks ago, that have really changed things in terms of what the future of Java is going to be. And not just in terms of the technology. So this is what we're going to talk about this morning, is what is the impact of a lot of these changes, and what does it mean to you as developers? Right, so the first thing is we're going to talk about JDK 9. JDK 9 was released in September. It was a long time coming. It had a number of delays. There were a number of hurdles that had to be overcome around the big feature in JDK 9, which is modularity, Project Jigsaw. So who here is using JDK 9? Interesting. Who's tried JDK 9? Okay, good. At least a few people have done that. Now, that's not surprising to me, because in talking to people, I've discovered that there is less willingness to adopt JDK 9 than JDK 8. So who's using JDK 8? Yeah, see, there you go. Right. Now, JDK 9 actually has a lot of changes in it. There are all this thing that's listed here. Big changes, small changes. But really the most significant one is this idea of modularity. It's about the platform rather than the language, rather than the libraries, which we're used to being changed. So lots of changes still in JDK 9. And one of the presentations I've done a number of times is 55 new features in JDK 9. And like I say, there are plenty of things that you can actually talk about here, but we're not going to talk about a lot of those. What we're going to do is we'll talk a little bit about the platform module system. This is Project Jigsaw. Now, what this means is that the runtime libraries that you have, so this is the good old rt.jar file that we're used to, that has been broken up. And the reason for that is that when Java first came out, JDK 1.0, there were about 200 classes in the standard class libraries. Over time, more and more libraries have been added to that. And JDK 8 has about 4,500 classes in rt.jar. That's wonderful because it means that now you don't have to write a list class, you don't have to write an SQL Connect class. All of the things that you need are pretty much there, all the basic classes. But the problem is that you've got this big file, and you have to use that for every application, even though you might not need all of the classes that are in there. So what they've done is they've broken that up into a number of modules. And these modules, there are 97 of them, and there are 28 of them which make up Java SE. Java SE is the standard that's defined through the JCP. So these are all the standard classes. But there's a whole number of other ones around that as well, which make up things like JavaFX. There's some Oracle-specific ones. There's JDK-specific ones. So there's no more rt.jar file, no more tools.jar file. The other big thing, which is very significant about the other thing that's very significant about the modularity system is that the internal APIs have now been encapsulated, or mostly encapsulated. The reasoning for this is that when the classes that were developed for public use were developed, they needed other classes. And these are the private ones. And the most infamous of these is sunmisc unsafe. Who's used sunmisc unsafe? Ooh, not many people. Who uses a framework or a library? Yes, so you're probably using sunmisc unsafe. You just don't know it. That's significant because the libraries that use sunmisc unsafe won't necessarily work straight away with JDK 9. And there are a number of other things which are kind of incompatible in that sense. So what you need to do is you need to look at your application if you're going to move to JDK 9, and you need to look at how it uses any of those internal APIs, either directly or indirectly through frameworks or third-party libraries. And the other thing that's quite significant is that we are moving away from using the class path to using the module path. You can still use the class path, but the idea is that when you develop modules and you break your application up into distinct units, then you move them to the module path. And the module path gives you more flexibility, it gives you more performance because it doesn't have the same problems as the class path. Now, looking at compatibility, this is quite an interesting thing. I've actually taken a direct quote from one of the product managers at Oracle, and he says, clean applications that just depend on java.se should just work. That's a fairly kind of precise statement, and they've used some deliberate language there. But it also is a little troubling because it means that the applications that you have may not work with JDK 9. So let's see what we mean by this. Okay. The important thing here is that the module system, the 28 modules that make up Java SE, one of them is a meta module. And this meta module is called java.se.ee. And there are 6 modules which make up that meta module. And in those modules, there are things which you won't get included by default. So even though they're part of the Java SE standard, they're not included by default when you compile your code or when you run it. Now, there are ways of getting around this, but it is something that you need to be aware of when you're developing your applications and when you're moving to JDK 9. Now, talking a little bit more about existing applications and portability and migration. Initially, what you can do is you can take your existing application and you can just move it directly to JDK 9. You don't have to, in theory, make any changes at all. So long as it relies only on java.se and doesn't have any unusual references to internal APIs, then it should just work. So you leave everything on the class path and you can run your application. Anything which you put on the class path becomes part of what's called the unnamed module. So this is how they've allowed the migration of applications from JDK 8 and earlier to JDK 9, is by saying that we want to use the module system. If you leave anything on the class path, that becomes part of a module which is unnamed. In terms of the way that interacts with other modules, it has a dependency on anything which is on the module path, and it can use anything directly through that. And it exports or makes available all of the packages which are available in those things on the class path. So it's a simple way of moving from JDK 8 and earlier to JDK 9. What you can then do is you can start migrating your code to using the module system. And the easiest way to do that to start with is to take your jar files and move them from the class path to the module path. If you do that, they become automatic modules. Automatic modules are ones which don't have module-specific information, but you can use them on the module path. So again, The way that works is that they will have a dependency on all other modules on the module path, and they will make available all of the packages that they have in those jar files. The name of the module will be the same as the name of the jar file. So again, it's a simple way of moving gradually to the idea of using modules. Now, one of the big problems was that initially, the developers of JDK 9 wanted to encapsulate all of the internal APIs. They just said, let's turn them off. We've told people right from the very beginning that they shouldn't be using these APIs, so we're going to take them away. That didn't prove to be very popular because obviously lots of people had used these internal APIs, and it was going to break a lot of code. So the decision was made that there needed to be a migration path between JDK 9 and later versions of the JDK. What they did was they introduced this thing called the big kill switch, which I think is a wonderful name for a command line option. And what the big kill switch allows you to do is to turn off encapsulation, so you can still access the internal APIs, and do it in a number of different ways. So there are actually 4 different arguments that you can specify with this command line flag. First of them, which is the default, is permit. And what that will allow you to do is to use the internal APIs. If you then use one of them yourself, you will get a warning message only for the first time that you actually use it. So if you use it 10 times, you only get 1 warning message. The second option you can use is warn, and that will give you a warning every time you use a particular internal API. Use it 10 times, get 10 warning messages. Debug will do the same thing. It will give you a warning message every time you use an internal API, but it will also give you a stack trace so that you can see how you got to the point where you'd use that API. And then the last one is deny, which is effectively turning off the ability to get to internal APIs. And that's what will become the default at some point in the future. Now, you can also break encapsulation in a more controlled way. So rather than just turning off encapsulation altogether, you can say, right, I know that I have certain pieces of code which use certain modules. So I'm going to set the flags so that only those modules, only those pieces of code can use the internal APIs that they actually require. So add exports allows you to do that for places where you have imported a particular internal API. So you've done an import and you want to use it. So you can either do that specifically for a particular package. So you can say, okay, I want to allow the Java management remote internal package to be available to my test package. Or you can say all the things on the unnamed in the unnamed module, which is anything on the class path. So in that case, the Sun management package would be available to everybody on the class path. So again, there's different ways and different granularity that you can use for providing access to these internal APIs. Many people access these APIs through reflection. So there's another command line flag, add opens. And what that will do is it will allow you to say, in the case of the Java util, give me all the internal APIs in Java util and allow them to be accessed reflectively from any of my code on the class path. JLink is a new piece of functionality which is related to the modularity. What this allows you to do is to say, okay, I want to create an application, and I know my application doesn't require all of the modules of the JDK, which is basically any application that you design. JLink will allow you to create a runtime for your application which only includes the modules that it requires. So what you can do is you can run JLink and you can specify various command line options for your application, and that will generate a directory structure on your machine which contains, in effect, the JDK. So you've got a bin directory, you've got a conf directory, you've got a jmods directory, there's a lib directory, and so on. In there, you will only have the modules that you need specified on the command line. And if you then go into the bin directory of that directory structure and run the Java command in there, and you specify list modules, it will tell you which modules have been configured for that particular runtime environment. In this very simple case, all I've done is include the Java base module. Java base is the most fundamental module, and everything has to use Java base. It's kind of like the object of Java modules. If we look at a slightly more realistic example where I've taken a simple application and I've said, create me a runtime for that application, here is the module which contains my main method and my main entry point. What the JLink command will do is it will work out the dependencies of your application. So you don't have to bother specifying them. It will look at the module for all app. It will read the dependencies of that module. It will then figure out what other dependencies those modules have, generate a transitive graph of those dependencies, and then include those modules. So in this case, we can see we've got Java base, we've got Java logging, Java SQL, Java XML, and then 3 of my applications, Azul app, Azul Zoop, Azul Zeta. Now, the other thing you will see there is that there is an extra bit of information there. There's an at9 and an at1.0. And you might be getting a little bit excited and thinking, oh, look, we've got versioning. No, we don't have versioning. That is one of the big things with the Java Platform module system is that the designers have said, no, we're not supporting versioning. So it's not like OSGI where you can have different versions for your bundles. In the Jigsaw world, you can't have different versions and then select which version you actually want to use based on various things. So that information there is just for your interest. It doesn't actually play any part in the application code. Now, JLink has some implications, and these are quite important. And Java has, right from the very beginning, had this idea of write once, run anywhere, or write once, test everywhere, as many people refer to it. It's been a long-term slogan of Java, and it has pretty much worked up until now. So there's been no problems with this. But one of the things is that if you look at the history of Java, you go right back to the very beginning. In the late 1990s, Sun Microsystems sued Microsoft over their use of Java. And the reason for that was that Microsoft had said, yeah, we like Java at that point, and we want to make it better. So what we're going to do is we're going to change the classes which are in rt.jar. We will add some classes to the Java packages. We'll actually take a few out that we don't think should be there. And that made things incompatible. And that's why Sun sued Microsoft. Eventually they won. Microsoft by that time had obviously gone off and created C# and .NET. But it was the idea of trying to maintain compatibility. So if you think about JLink, the issue here is that what you're doing is you're actually creating a subset of the modules, which means that you now don't have all of the Java APIs there. So in theory, you lost write once, run anywhere. And what you can do is you can generate a runtime which doesn't necessarily include all of the Java SE modules. However, this is still a conformant Java implementation. If you look at the Java SE specification as defined through the JSR, you will see that it actually describes that things like JLink can create a runtime image which doesn't include all of the modules, but it is still classified as Java. This is actually a big change for Java because it's very different to what we've had in the past. In order for a runtime image to be conformant, it has to do a couple of things. The first is it has to include the Java base module. Because all modules depend on java.base, either explicitly or implicitly, you have to include that. And the second thing is that if you include any of the other Java platform modules, it must include any transitive dependencies. What that means is that if you take the example I showed you on the previous slide, there was a dependency on java.sql. Java.sql depends on java.logging and java.xml. So if you include java.sql in your runtime, you must also include java.xml and java.logging in order for it to be conformant. And anything which does that is defined as a closed implementation. So as I say, this is quite significant because it does mean that from the point of view of runtime images, you don't have to include all of the libraries, and it is still classified as Java. Right. Now let's start looking at some of the things which have changed more recently. About 3 weeks before Java 1, there were a number of announcements about the future of Java. And these things are going to have quite an impact on how we use Java and how Java changes over time. So let's have a look at some of those. So the first thing is that the OpenJDK. OpenJDK is the reference source code for Java SE. So this is what Oracle used to build their binary distributions. It's also what we at Azul use to build our binary Java distributions. And what they've said is that instead of waiting sort of 2, 3, 3.5, maybe 4 years between Java releases, what they're going to do is they're going to come out with a new Java release every 6 months. Now that's a really fast schedule compared to what we used to. Because if you look at JDK 6, JDK 6 came out at the end of 2006. JDK 7 came out in 2011. JDK 8 came out in 2014. And JDK 9 has just come out in 2017. So we've had 4 releases in 11 years. We're now going to have 2 releases a year. OK. So the idea is that they will have a release in March, and they will have a release in September. And that's going to be fixed. So every March, every September, there will be a new release of Java. And that's going to start next year. The idea behind this is to make the development of the OpenJDK, and therefore the Java platform, more agile. A lot of developers have said, we really like Java, and we like using Java, but there's certain features which would be really nice to have in the language. It takes a long time to add those things, because if you have to wait 3 years or 3.5 years for a new feature, it's a long time. So why not bring out things as they're available? So as soon as something's available, we can put it in the next release. Within 6 months, it's going to be in the platform. So this is the idea of having a much more fast release pace, the idea of being able to get features in more quickly, only when they're ready. This changes the way that the Java platform is developed. Previously, the way that things worked is that when JDK 8 came out, the planning was started for JDK 9. So it was like, what features are going to go into JDK 9? And only when all those features were ready was JDK 9 launched. So the launch was based on the features. Now it's been turned around. So it's the launch is based purely on a date. Anything that is ready can be included. If a feature is not ready, it gets pushed back to the next release. And if it's not ready, then it gets pushed back again. So it's only when things are actually ready to ship, they get included in the JDK. Right. The next thing that Oracle have announced is that the JDK is going to be more open source, specifically around a couple of things which Oracle have had for a long time now, called flight recorder and mission control. So these are things which they've had as commercial features. They came as part of the JRocket acquisition that they got through BEA, and they've been using those for a long time. They've supplied them as part of the JDK, but as commercial features. So you couldn't get access to the source code. You could use them for free if you were doing development, but if you wanted to use them in a production environment, there was a licensing cost associated with those. And that was something which did catch a few people out in the past. So what Oracle have said is, we want to make all of that open source. They've said they want to do that by the end of next year, so that, in effect, all of the things which they've had in the JDK up until now will become open source. Oracle's distribution will be purely open source based. Right, version numbering. Okay, now this is an interesting kind of thing to look at. I wrote a blog entry about this yesterday, and it turns out that if you look at the version numbering for Java, the version numbering scheme actually changes almost as often as the version of the JDK. We've been through JDK 1.0, sure. Okay, 1.0 makes sense. Then we had 1.1, then we had, remember, Java 2 SE version 1.2, then there was 1.3, then there was 1.3.1, then there was 1.4, 1.4.1, 1.4.2, 5, so then there's a bit of a jump. Then it was Java SE 6, so they dropped the 2. Then it was 7, 8, and 9. Okay, so we've kind of gone through a fairly weird numbering scheme. But in JDK 9, the decision was made to introduce a new version numbering scheme. And it was going to be nice and simple to understand, easy for machines to interpret, easy for humans to interpret. So they said the JDK will be defined as a major number, a minor number, and a security release. Great, 3 numbers, so you get 9.0.1 or something like that. Semantic versioning, easy to understand. Great, except that didn't last very long. So that went away. So we decided that that was too simple. We needed another version numbering scheme. The reason behind this was that with the decision to move to a 6-monthly release cycle, people at Oracle said, oh, okay, we're going to move to a 6-monthly release cycle, which means we know exactly which month that release is coming out. So why don't we change the version numbering scheme again? Yes, we'll have a new improved version. What we'll do is we'll have year.month. And this is the same as, if you use Ubuntu, then you're familiar with the idea of, 1404 or 16.0, was it 7, I think, or 8, whatever. So now we have JDK and then the year and the month, which means that we've got JDK 9 now, and the next release would be JDK 18.3. And then we'd have 18.9, 19.3, 19.9, and so on. Great. A lot of people in the community were not really very impressed by this. They said, this doesn't really make sense. It doesn't really reflect enough information about what's going on with the versioning and so on. So as of actually just last week, that one has gone away. So there is a new proposed scheme. So that still hasn't been decided. And the new scheme is this. So we're going to have feature, interim, update, emerge. Now, why they didn't call it emergency, which would be very logical, obviously they decided it was too many letters to type. But anyway, so the feature is going to be the same as the major was in the JDK 9 scheme, which means that we are going back to having the next release being JDK 10, and then we'll have JDK 11, 12, and so on. Great. Interim was the minor number, and effectively, that isn't used. So this has been placed there for future expandability. But for now, it's not going to be used. So all the releases are going to be like 10.0. something or 11.0. something. There's no proposal at the moment to have a 10.1 or an 11.2 or anything like that. Update was going to be security, and now it's pretty much the same as security, except that it has a slightly different rule about how you increment it, because it means that you don't have just security updates. There's also normal updates that get included in that as well. And then there's the emerg number at the end, which is emergency. So if they have to bring out an emergency patch to fix some kind of security fix before the schedule for the release, then they can use that 4th number as well. And in fact, if you read the definition of this, they also say that you could add a 5th number if you want. So for people who are building OpenJDK binaries, if you want to add 5th or even more numbers, then you're free to do so. So this currently is the numbering scheme that we'll be using for Java moving forward. Right, availability of JDK updates. This is quite significant as well. Oracle have decided that they are moving to a different way of supporting Java as a platform. Now, up until now, the way this has worked is that when, like for example, JDK 8 came out, that had public updates available until the next release came out, and then sometime after that. So if we go back to Java 7, when Java 8 came out, there were still public updates for Java 7 for, I think it was 2 years after Java 8 came out. But after 2 years, Oracle stopped giving public updates, which meant if you wanted updates to Java 7, you needed a commercial support agreement with Oracle. That gave people 2 years to move from 7 to 8. What they've now said is, well, with a move to a 6th monthly release cycle, we don't want to be doing 3 years of support for every one of these releases. The way we'll do that then is we will use a long-term support idea. So this is, again, kind of similar to what Ubuntu do, where certain releases are designated as a long-term support release, and the ones which aren't don't get long-term support. The idea is that if it is a long-term support release, that will have 3 years of public updates. After 3 years, public updates will stop, and you'll have to either move to a newer platform or get a commercial support contract with Oracle or somebody else. So JDK 8 has been defined as a long-term support release. Now, that immediately means it's going to get more than 3 years of public updates because it's already over 3 years old and it's still getting public updates. But that's just to kind of synchronize on the flow of things. The next long-term support release is going to be in September 2018. So 18.9 or 11, depending on which numbering scheme we're going with. Anything which is not a long-term support release is called a feature release. So a long-term support release is also a feature release, but anything which is not a long-term support release is a feature release. JDK 9 is a feature release. So this is kind of a little bit unexpected, but JDK 9 is a feature release, which means it doesn't have 3 years of updates. That means that in March next year, public updates for JDK 9 will stop, which when I ask who's using JDK 9, you're probably thinking, ooh, that's good. I'll wait a little bit longer before I move to JDK 9 so that I can get the long-term support of public updates. So JDK 9 will stop having public updates in March next year. Next long-term support, as I say, is September of next year. Right, other things that are being changed. Deprecation is something which has long been used in Java as a way of signifying what things the developers wanted to remove from Java. Because when you develop an API, when you develop a platform, quite often you want to add things, but there's also situations where you think, well, that probably wasn't the best way of doing it, so we want to remove that. So there are literally hundreds of classes and methods and interfaces which have been deprecated. Up until now, none of them have actually been removed. So JDK 9 actually breaks with that tradition. And there are actually 6 methods that have been removed from the standard class libraries in JDK 9. They were deprecated earlier on. Other things are now being deprecated. So you need to be aware of this, because this is going to have an impact as Java moves forward. So one of the first things that has been deprecated is the applet deployment mechanism. Who's using applets? Oh, okay, right. So you're going to have to do some thinking about this in the long term. But at the moment, applets, not many people use applets. The whole browser plugin thing really kind of makes it a bit redundant now. So applets as a deployment mechanism, that's going away at some point soon, and I think it probably will be very soon. CMS, who uses CMS as a garbage collector? Ooh, not many people. Okay, that's interesting. Well, CMS is going away. Now, there are a lot of people who are not very happy about that, so it may be that that will stay for a bit longer, but CMS has been deprecated. Oracle think that they don't need 3 garbage collectors, CMS, Parallel Collector, and G1. I guess most people, G1? Most people using G1? Parallel? Who's not using a garbage collector? Interesting. Anyway, so other things, there's some small things which are getting deprecated. Java Policy Tool, JConsole, Doclet API. You can find all the details of this if you search for it through the documentation. One of the big things, though, that has been deprecated is the java.se.ee meta module. So I mentioned this earlier when I talked about JDK 9. In JDK 9, if you compile and you use any of these modules, Corba, transaction, activation, XML bind, XML web services, XML web services annotation. If you use any of the packages from those modules and you try and run your application on JDK 9, it will not work because it won't be able to resolve those packages because they're not included by default. I found a really good example of a program which fails because it uses one of those things. Anybody want to guess what it is? Minecraft. Minecraft will not start because it uses one of the XML binding APIs for something or other. So it won't actually start on JDK 9 without some extra command line options. But this is something which is quite significant because this has been deprecated, and so the idea is that these will be removed at some point in the future. So just again, out of interest, anybody using Corba? Oh, one person, okay. So again, you'll have to be thinking about what to do in the future. Right. Binaries. Another thing which is being changed. In the past, Oracle released binaries of the Java runtime, the Java development kit, and they make them freely available. But they make them freely available under the Oracle Binary Code license. So when you go to the Oracle website and you want to download the JDK or the JRE, there's a little button you had to click to say, I accept the license. I've no idea what the license actually says because, like I'm sure most of you, I just go click and I accept it. I've got no idea what I'm saying I do, but it's click-through license. What that does mean is that there is this classic field of use restriction. A field of use restriction goes actually back in history to when Sun was making money from Java in embedded devices, Java on mobile phones. And so it was a restriction which said you can use Java for free if you use it on a general purpose computer. If you want to use it in an embedded device, if you want to use it in a kiosk or a mobile phone, then you have to license it and you have to pay a licensing fee. So there is this classic field of use restriction. What Oracle have said is that in the future, they are going to release binaries for all of the releases under a GPL version 2 with class path exception license. That means that you are no longer restricted in terms of where you can use it. So there is no more field of use restriction. You can just take it, use it wherever you want. So all of the releases that Oracle provide will be released under a GPL v2 with class path exception license. But they will also, for the long-term support releases, release it under the existing Oracle binary code license as part of the sort of long-term support idea. They've also made some other changes. So they're no longer 32-bit binaries available. So if you're using Windows 32-bit, that's gone. No more ARM binaries. So if you wanted to use JDK 9 or later on an embedded processor and ARM, those have gone as well. Talk to me if you want those things. Windows, Linux, Mac, and Solaris Spark are the only platforms that are being supported by Oracle as binary releases. And those are all going to be 64-bit. So 4 platforms, and that's it. Let's talk about JDK, and I've used .next because I wasn't quite sure what the number was going to be, so we'll just pattern match and then search and replace. Right, so JDK 18.3 or 10, whatever. This has already started in terms of work. So there is a JSR that has been submitted to the JCP, which will be the specification for Java SE 10, let's say. Brian Gertz is the spec lead on this, and there are what I would describe as the usual suspects on the expert group. So Oracle are there, IBM, Red Hat, SAP, and Azul. I'm actually the representative for Azul on the expert group for this. The schedule has been approved, so development will be complete at the end of December. So it's, tight schedule. Release candidate in February, and then general availability towards the end of March. There is already an early draft review available, so if you want to look at what's going to be in JDK 10, you can find out the details of that from there. And in fact, I did just that. So at the moment, there aren't many changes. There are one big one, and then there's a few small API things. So the small API things is that things like properties has a new replace method, the concurrent future task has a new toString method, and then there's some methods in stack frame and stab lock which have been added. So not very exciting. The big thing, though, is that local variable type inference is being included. This is quite a significant change for Java, because now what it means is that you don't have to explicitly state the type of a variable when you create it. This doesn't mean that we're moving to dynamically typed Java. It's still very much statically typed. It's just that the compiler will infer for you what the type of that reference actually is. So in this case here, we say var list, and we're going to assign it to an array list of type string. So the compiler will infer that the type of list is an array list of type string. So it simplifies things because we don't have to specify array list of string twice. Great. Similarly, if we then use that list and we get a reference to a stream from it, we can assign that using var stream, and the compiler will infer that because the list is an array list of type string, that the stream will be a stream of type string. Some languages use var and val, val being to define that something is a fixed value, so it can't be changed. But because Java already has finals, then it doesn't actually make sense to use val as well. So we only have var, and the compiler will infer the type for us. Longer-term JDK futures. Obviously, there's a lot of ideas about things that should go into Java. And there's various projects and various suggestions about what could potentially go into Java. So I thought we'd just spend a few minutes looking at some of the ideas that might turn up. So these are what are called JEPs, JDK enhancement proposals. This is a way of doing things that's been used since JDK 8. Essentially, what it means is that anybody who is a committer to the Open JDK project can submit an idea for something that could be included in the JDK. And it's designed to be sort of reasonably small pieces of work, not kind of 2 or 3 line changes, but not like Project Jigsaw, that kind of thing. These are the ones that I picked out which look reasonably interesting and may be in a fairly near-term version of Java. So there's JEP 304, which is a garbage collector interface. Now, that's not a programming interface between the application code and the JVM. This is actually internal to the JVM, so that if you want to change the way that the garbage collector works, you've got a nicely defined interface that you can just take your design of a garbage collector and just plug it into the JVM, and it's easy to integrate. So obviously for us at Azul, because we have our own garbage collector called C4, this is make life easier for us to move C4 from version to version, because it's just keeping the same interface. Pattern matching. So this is the idea where you have code where you're looking at the type of an object. So you do, if something is an instance of a particular type, and then you want to do something with it. And there's a lot of situations where you might do that, and you've got extra boilerplate code that you don't really want to have to do. Because the classic example is you say, if, let's say, if x is an instance of integer, and then you want to use x, you have to explicitly cast x to be an integer in order to be able to use it. But you've already just tested that it's an integer, so you know the compiler knows it's an integer, or the JVM knows it's an integer. So it's things like that where you don't want to have to do that every time. So pattern matching is a way of eliminating the need for that. And so there'll be 2 different things that they're going to start with. One is to be able to do it in an if statement, and the other is to be able to do it in a switch statement. So you could have a switch statement where you had different types, and then you could use different calls on that object based on its type without having to do an explicit cast. JEP 310, application class sharing data. In earlier versions of Java, we've had this thing called the class data sharing area. And what that allows JVMs to do is to share the classes that they use. So if you've got multiple JVMs all using the same set of classes in the JDK, then they don't have to have their own copy of it. They can all share one instance in memory. That's been extended in JDK 9, so now you can also store strings in the class data sharing area between JVMs. The idea is to extend that so you can also include your application code. So if you've got multiple JVMs all running the same application, rather than having to have their own copy of your classes in their memory area, you can actually put it in the class data sharing area and reduce the load on the system. And then the last one I kind of picked out is JEP 3.12, which is thread local handshakes. This is, again, sort of buried in the JVM, but it's a good idea because it will help to reduce the problems of latency with certain applications. Because what the JVM has to do is, if it wants to pause one thread, it has to wait for all threads to reach what's called a global safe point. And by doing what's called a thread local handshake, it enables single threads to be stopped individually, and so not have the overhead of having to wait for all the threads to reach a global safe point. So it should have an improvement in terms of performance. There are a number of projects that have been started in the OpenJDK. So the first of those I've just mentioned is Project Amber. Now, Project Amber is made up of 3 different JEPs. First of those is the local type inference, local variable type inference, which we all said is going to be in JDK 10. Enhanced enumerations. There's a couple of things that they're doing there. This is, I have to say, this one's a little bit more esoteric. So what they want to be able to do is to have an enumeration which can have a generic type associated with it. And then you can also, in that case, you can have a method which returns an object of a type. So it's kind of extending enumerations into almost like a class-like structure. But as I say, I looked at the description of that. I thought, I'm not really sure where I would use that at the moment. But maybe there are some good examples. And the last one is JEP 3.02, which is Lambda leftovers. So there are 3 things that they're doing there. One is that in JDK 9, the single underscore became a reserved word. So you can't use it as a variable name. Anybody use a single underscore as a variable name? Good. I have to say, though, if you're really dedicated to that idea, I checked this, and you can still use 2 or more underscores as a variable name. But the idea in JEP 3.02 is that if you have a Lambda expression where you have a parameter that's in the Lambda expression, it's not used in the body of the Lambda expression, then you can use a single underscore to sort of hide that parameter. So it makes it clear that it's not being used in the body of the Lambda expression. Shadowing of Lambda parameters. This is if you use the same variable name in your Lambda as a variable you have in the surrounding scope. That won't work at the moment. The idea is that that would work in the future. And better disambiguation of functional expressions is because the compiler could use type inference to figure out what is the type of the functional interface which your Lambda expression represents. There are situations where you may have overloaded methods which have different types associated with them. And when you use the Lambda expression, the compiler can't actually resolve to a single type. So in the case of this, there are situations where the compiler can do better. So that's what they're aiming for with that. Project Valhalla. This is one that's been around for a little while, and it's an interesting idea because it is a substantial change in terms of Java. What it does is it looks at the idea of adding value types to Java. Okay, so why would we need value types in Java? Okay, so this is my Yoda slide. So identity leads to pointers. Pointers lead to indirection. Indirection leads to suffering of performance, right? So in Java, we have objects, but Java is not a truly object-oriented language because we also have primitive values. And the idea behind having primitive values was because when Java first came out, the performance of having purely objects wasn't good enough. So primitives were put in there so that you get better performance. Problem is that objects work very well because you can have encapsulation, you can have polymorphism, you can have inheritance, and all the good OO things. Right. But Often what we might want to do is use those primitives in conjunction with objects and in conjunction with generic types. So we might want to create an array list with ints in it. But what we can't do is we can't create an array list of int, because int's a primitive, so it's not a type in the sense of an object. So we can't actually do that. So we can do array list of integer and use the wrapper class representation of the primitive, and we can do that. The problem with that is it requires boxing and unboxing. So every time you add an int to your array list, it's got to create an object, it's got to be put into the object, and that is then stored. When you get it out, you've got to unbox it, you've got to take the value out of the object and return it. Bad. So the problem with that is that lots of performance impact. Object creation, heap overhead, indirection reference, all of those things reduce the ability to get performance out of that kind of thing. So value types are designed to do what we want. It's the idea that it codes like a class, works like a primitive. Rather than having to have an object reference and store it on the heap, we can actually use a primitive, but treat it like it was a class. So we can have methods and fields, we can implement interfaces, we can use encapsulation, we can use generic, it can be generic. All of those things can be done, but we don't have the overhead of objects. So that the storage underneath, even though it appears to us as being like an object, the way that it's stored underneath is actually much cleaner and doesn't require all of the overhead of boxing and unboxing, object creation, and things like that. So a lot of work going on that. Not sure when that's actually going to be included in Java, but it definitely is something that's kind of high up on the list of things to do. Project Panama. Again, this has been around for a little while, and this is the idea of making life easier from the point of view of native code interaction. We've had JNI for a long time, and that allows us to, interact with native code from Java. But if you've ever used JNI, it's not easy. And I remember talking to one of the engineers who developed JNI. I said, it's a bit fiddly with this. And he said, yes, that's because we designed it that way. It's like, what? Yes, we wanted to make it difficult to use to discourage people from using it. And you're like, okay, that's not a good design philosophy to start with, is it? But anyway, so the idea of Project Panama is to have more of a foreign function interface. So you'll be able to have things like native function calls from the JVM to C and C++. There'll be direct data access from the JVM and inside the JVM heap. Header file API extraction tools, because Java 8 is actually going to go away I think in Java 10. Native library management APIs, and then some hooks for how we can do class and method resolution from native code and so on, and native-oriented JIT optimization. So there's a lot of work going on there to simplify the interaction between Java and native code. And then the last one I want to talk about is a very recent announcement, which is called Project Loom. And Project Loom is looking at how to make concurrency in Java even easier. Now, right from the very beginning, Java has tried to allow developers to use multiple threads and do it in as a simpler way as possible. So JDK 1 introduced threads, JDK 5 gave us the concurrency utilities, so things like semaphores and atomic locks and rewrite locks and things like that. We then got the fork join framework in Java SE 7, we got parallel streams in JDK 8. Project Loom is looking at how to improve the efficiency of using lots and lots of threads. Because a lot of applications nowadays, especially sort of web-based applications where you've got lots and lots of clients all hitting your server simultaneously, what you want are lots and lots of threads. And what we've seen over the sort of past couple, probably 2-3 years, is this idea of reactive programming has become very popular. The whole asynchronous way of doing things, so threads don't ever block. The problem that we have is that threads at the operating system level, which is what you map to the threads in the JVM, are just too heavyweight. So you can't create millions and millions of threads unless you've got a really, really big machine. So too much interaction with the operating system. Solution to this is what are called fibers. And fibers are essentially abstracting threads at the JVM level. Anybody remember green threads? Oh, good, a few people there. Good, I like to see that, yes. So it's kind of like the same idea as green threads, where you implement a threading model at the JVM level. And what that really involves is two things. One is adding continuations to JVM, and the other is using the scheduler, which is already in the fork join pool framework. So that will actually provide most of the support they need there directly. The idea is that these fibers will be much, much lighter weight than threads. So they'll use a lot less memory, and they'll be, as they describe it, close to zero overhead for task switching, which obviously there isn't if you're using the operating system threads. So it really is designed to make using lots and lots of threads very, very easy and much better in terms of performance. So just to kind of wrap up, because I've literally got 2 minutes left. Right, so Java continues moving forward. I think that's definitely fair to say. JDK 9 is out. It has the platform module system. It has some big changes. There's quite a few things that you need to be aware of with JDK 9, which may break backwards compatibility. I've written some blogs on this that you might find interesting. And remember, JDK 9 is also not a long-term support release, so it's only going to have public updates until next March. Faster Java release schedule, so every 6 months, and every 3 years we'll have a long-term support release. OpenJDK binaries being released under a GPL v2 with class path exception license. It's all good stuff. And lots of ideas for keeping Java moving forward. So value types, better JNI, type inference, lots of small ideas as well. And then the last thing I'm going to say, this is my marketing slide, which is just to briefly mention about what we call Zulu Java. So we, as Azul, we build OpenJDK binaries. And the important thing is, even though this is a marketing slide, we make them available for free. So you don't have to pay us any money. You can go to our website. You can download our binaries of the OpenJDK. We build them. We run the TCK on them. So we guarantee that they pass all of the tests. They are fully conformant to the Java specification. We support multiple platforms, Windows, Linux, Mac. We also have ARM versions. So if you want ARM versions, you can get those from us. As I say, they're completely free, but if you want support, we're very happy to sell that to you at a very reasonable cost, I would say. We do support JDK 6, 7, 8, and 9, and we're looking at how we want to do support for the upcoming releases. So we may do things differently to the way that Oracle do it. So come and talk to me if you've got any interest in support for Java. And as I say, you can download those there. So that is it. Thank you.
Okay, thank you. We have just a couple of minutes probably for 1 or 2 brief questions. So guys, if you have questions, please raise your hand. And volunteers will give you the microphones.
Hello, hello. I sent some. First of all, for you, a lot for presentation, and 2 questions. So the first question is all these changes in JDK 9 and 10, what does it mean for other vendors like IBM, SAP? Do they continue the same model with supporting their JDK versions and like that? And second question regarding, let's say, for example, pattern matching. Does it mean that you're going to support algebraic data types as well as other stuff from functional world? Okay.
Right, so the first question about people like IBM, SAP, as I said, they are all on the expert group for the new versions of Java. So my understanding from talking to the people at IBM and SAP is they will do the same thing. They will track the new versions and they will be releasing every 6 months. Although what they'll probably do is focus on the long-term support releases. So they'll do the every 3 years as the platform they use for supporting things like WebSphere and stuff like that. Second question was about pattern matching. You said, I didn't quite... Sorry?
Pattern matching. Does it mean that you will support algebraic data types like case classes like in Scala and like that?
Oh, I see. Okay. I'd have to say I'm not completely sure. Like I say, at the moment, there's only 2 things that they're actually focusing on. One is like an if statement, and the other is supporting it within a switch statement. So I think we'd have to talk about that a little bit more to see. But at the moment, I don't think so. Okay.
Well, thanks a lot for answering the question. I just